I've had training.
The training is nothing. The will is everything.
The will to act. Yield.
This time for
Chemistry.
Yeah, baby. Yeah.
Oh, there we go. That took a little bit of time. Yeah, cool. Okay, finally, I got a bit of audio. Yeah, I've got the flu, so I'm all over the chip shop, whatever. What the hell is that echoing so bad? Hold on one sec. My sound's gone funny. It's what happens when I'm not on here for a while. This thing goes up the creek. Give me one sec, peoples. Can you hear me now? Let me see. That might be better. I think that's better probably. Anyway, going to go through some nomenclature. What I did is I went through all of the OCR A-level chemistry and AQA A-level chemistry exam papers and found every time it said, can you name this? Can you name that? And I thought, let me compile it into, let me just teeth out all those questions and then do a quick 1 hour live on it. See if I can name everything that comes up. So there we go. Right, I'm gonna need glasses on. Yeah. A lot of flu going on. A lot of flu going around. Pretty grim. So this is not as grim as my glasses though. Right. Name compound C. So it exists as a cis and trans stereoisomer. So they're giving us a clue. What is the name of compound C? And then a chemist investigates. Oh, I mean, the fact that it exists as a cis and trans stereoisomer, we don't need to say cis or trans. Okay, so we don't need to give it the old, we don't need to give it the old EZ, because we can't tell from this, because it could either be E or Z. But what is its name? And then a chemist investigates two reactions of alcohol A shown below. What is the systematic name for alcohol A? See if you can slap that up there and work out the name of that. So this is actually from the 2017 OCR Chemistry A-Level Paper 2, the organic paper. You can see there's 1, 2, 3, 4, 5, 6. So that makes me think these carbons are all in a row. We can see they're giving us the structural formula. Nothing's in brackets. We shouldn't even have to draw this out. So this looks like it's hex as the main chain. Then we got a double bond there, which where's that double bond? Where do we start numbering to find the double bond? What is more important, the alcohol group or the double bond? It's all about your priorities. The alcohol is more important here, so it's going to be hex, and we've got a double bond, so N-ol, and then we just need to number it. So we'd start by numbering the alcohol double bond as 1, 2, so it's hex 3 because the double bond appears on carbon 3. So you do a hyphen, a straight line, hex 3, En tells us that it has a double bond. It's got an alkene, obviously, in there, double bond bit. So through hex 3En, I guess you could put 1-ol, or you could put ol, you know. You could say hex 3En-ol or hex 3En. I suppose we want a number where it is 1-ol. They'll probably accept it without that. And hopefully that makes sense. Now, any questions about that? You don't need to put E or Z because it can be either. So we don't know from this formula exactly whether it's E or Z. All depends where that ethyl group is there, where that hydrogen is there. Okay, let's have a look at the one below. It will be hydroxy, like important 452, if you are dealing with a carboxylic acid. Now, carboxylic acids are the big Mac Daddy. So if something has a carboxylic acid, then it will normally end oic acid. So carboxylic acids are the big bad cheese. And basically, then your OH is going to be a secondary, it's going to be a side group, and then it is hydroxy. In fact, let me show you the priority. It's not 100% this, so don't go off of this. Where's the priority list? Oh, there we go. So I've got a little priority list. This is just off the old Google AI, but you know, you can go in and look at, there are websites which deal with it. Carboxylic acids, essentially oic acid is number 1 Mac Daddy, and then after that there's a lot of things with equal priority. So look, number 3, carboxylic acid derivative. I mean, you don't really come across that at A-level, sulfonic acid, so you don't have to worry about that. You'll come across acid anhydrides, esters, acid halides, amides. These are all kind of equal priority, these carboxylic acid derivatives kind of thing. And then you've got nitriles. So for instance, if you had a CN and an OH, it would be hydroxynitrile. Okay. Aldehydes, ketones, alcohols, thiols, amines, alkenes, alkynes, alkanes. Although, to be honest, these ones down here are all the same kind of priority. Like alkyl groups are the same priority as halo. Halo normally comes at the start, like chloro, bromo, and alphabetically you also say side groups alphabetically. But yeah, are you supposed to know that all off by heart? Roughly, but most of these things don't come up. There's only a few of these that come up. Okay, so a chemist investigates 2 reactions of an alcohol shown below. What is the systematic name of alcohol A? So what would be the name of alcohol A? You want to give, obviously it's an alcohol, so it's going to end in ol, but it has some alkyl groups. They're going to be side chains. And we want to give it the lowest possible kind of priority, I guess. And we've got to find the longest unbranched chain. So I guess that's going to be there, 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 and there, right? Whatever way we do it. So that is going to be, well, see if you can work out what that's going to be. I'm not going to draw all the H's on, but you can see got CH3, CH3, And then I've got this up here. So in a way, the way I've drawn it, this is going to be my longest chain. And this here is going to be my side group. I know I've kind of missed a bond off there or whatever, but there we go. So yeah, what would we call this? Now, I want to give that the lowest number possible, as that side group is more important than that side group. So just, I'm going to number it 1, 2, 3, 4, my main chain. So I know it's prop. We know that the OH group comes off of the second carbon, so I'm going to call it propan. Where's the NU? Full propan 2-ol. And then I just need to bust out the side group, so I'm going to give it the old 3, because it comes off the third carbon, and methyl. You're going to use hyphens. Now, they're quite generous with your hyphens, so if you put one in the wrong place or you don't put one in, they'll generally be all right as long as you've numbered it correctly. You're right, it's butanol. I was just testing you, so well done. How can there be 4 carbons and it be prop? Oh my days, what the fudge have I done there? Okay, gone a bit funny there. You're right, it's butan. 3-methyl. Well spotted. Keep you on your toes. Now I've got an extra N. Let's get off of that one. It's just getting worse, isn't it, by the second? Right, 3-methyl-butanol. Okay. Do a couple more of these, if you can do them. I'm just going to go through a few of these. So, okay, so we've got these two here. We've got what is the name of the compound below. And this one's a multiple choice, as you can see. So is it A, 3-propyl pent 2-ene, 3-propyl pent 3-ene, 3-ether hex 2-ene, 4-ether hex 4-ene? Which answer would you go for? And then the structure of ester A is shown below. What is the systematic name of ester A? See if you can do that one, or those two, if you want. Don't worry if you don't want, because even if you don't want to hang about and watch this, you can watch it after, because I'm just going to go through and do a few of these until my hour is up. So I'll show you how to work it out. Whoa. We want to number this. Now, what's the most important part? You can see I've got, if I show you again, what's the most important part? Well, alkenes are right at the bottom of the priority list, but they are above side chains like alkyls. So they are more important than single bond carbon hydrogen groups or alkane kind of side groups. So alkenes take preference. So I want to number this in a way where I give this the lowest number possible. So I'm going to number this like this. I'm going to go, I like the look of C in port 45. I believe you are correct. So I'm going to number this like that. 1, 2, 3, 4, 5, 6. So you went C, and that would make sense to me. Look, 3-eth, 3-ethyl, and then we got hex and 2 for the double bond ene. Yeah, that sounds perfectoid. Well done. And then for the structure of ester A shown below, what is the systematic name of ester A? So again, they've told us it's an ester. Hopefully you remember how to name esters. You start with the bit that came from the alcohol. So originally this would have been ethanol attached there. So that's the starting point for the ester's name. So, oh my days. I'm going to give it the old ethyl to start with. Now, there are other ways you can name. Some of these have more than one systematic name. So I'm going with ethyl. And then how many carbons here? 1, 2, 3. So what we going? Ethyl propan 08. However, it has a bromo. Now, do you put the bromo in front of the ethyl? If you do that, it makes it sound like the bromo's coming off here. So in fact, we're going to go ethyl bromo propanoate. And probably need to number that, because if you number these carbons, that is, anyone put that there? Ethyl 3 bromo propanoate. Yeah, you're all over it. We go with that. And you can see there that would be 1, 2, 3. So yeah, ethyl 3. I get annoyed with writing. I need to type, because bromo writing on here, I'm like propan. Oh my days. Oh, hey, there we go. Ethyl 3 bromo propanoate. Right, let me do a couple more. See if there is. Okay. Prenal, shown below, is used in the synthesis of some pharmaceuticals. What is the systematic name for prenal? I mean, the A and L at the end tell you it's an aldehyde, don't they? So, what we got here? We get the aldehydes are quite high up the priority chain. So they're definitely ahead of alkenes and alkyl groups. So probably going to go 1, 2, 3. It doesn't really matter if I do it like that. Doesn't make a difference if I number it 1, 2, 3, 4, or I number it 1, 2, 3, 4. It's the same way really. So 1, 2, 3, 4, and then that's going to be my side group. Anyone got an eye? 3 methyl but2n al. Very good. Yes. Well done. Spot on. Let's put that in. What did you say? 3 methyl but2n al. Love it. Yeah. All right, now we've got this one down here. This question's about unsaturated hydrocarbons. The unsaturated hydrocarbon A shown below is reactive with bromine. Okay. What is the systematic name of hydrocarbon A? Oh, so we don't need to worry about the bromine. Just what's the name of that hydrocarbon? Well done for getting that pre-now. That looked quite hard. Okay, let's smash this one out. So what we got here, this looks pretty straightforward as well. So we want to number this where we give the carbon the lowest, the double bond, which looks like the most important part, the lowest thing possible. So 1, 2, 3, 4, 5, 6. So what we're going to say, hexene, and then we got the methyl group coming off for 3. So 3 methyl hex 2-ene. Sounds pretty good to me. And you can see the double bond is coming off the 2. We want to number the double bond with the lowest. Oh, but is it Z or E, this one? Is it Z or E? So it's definitely going to be 3 methyl hex 2-ene. But is this E or Z? Antigen, opposite, you reckon? So what we got there, yeah, you're right, because that H is a low pre. That's low priority over here, this H, because it has an atomic number of 1. But we can see that this propyl group definitely has a higher priority than the one there. So that is low priority, and then that is higher priority. Yeah, so it's antigen, not sisters, it's opposites. So antigen, E3 methyl hex 2-ene. Well done for that one. Boom! Right, where are we? Okay. Oh my god, I can't be just doing naming for an hour, can I? That's insane. But there we go. Yeah, I'm doing some nomenclature today. So what is the systematic name for the compound below? 3,5-dimethyl-octa-136-triene, 3,5-dimethyl-octa-257-triene, 4,6-dimethyl-octa-136-triene, and 4,6-dimethyl-octa-257-triene. What's nice here is that we know they've already done the triene for us. They've already told us it's octa. So it's just a case of, I think they're just varying in the double bond numbering. A, you think? Yeah, I think that's going to give it the lowest, right? Which is going to be 1. So what you do is you pretend you got all these carbs here. And then what we want to do, yeah, you're going to have 1 for the double bond, 3, 6 is the lowest way to do the double bond. If I went the other way, it'd be 2, 4. Yeah, that's going to be the lowest way. 1, 3, 6. You're right. And the methyls are on 3 and 5. Yep. Hey, nice one. Yeah, important 452. This is OCR. I'm going to switch to AQA for the next little batch. What do you think of these OCR ones? I'm going to switch to AQA for the next few. You think these ones are easier? Are you AQA or OCR? I'll switch to AQA. AQA, yeah, you can compare when I switch to AQA. I think the AQA, so the general pattern from what I could see today, because I was just stealing these from the paper 2, the organic paper, which is the same in OCR and in AQA. The organic paper is paper 2, and I was just teething these out of all of the A-level ones. In OCR, they seem to be about 1 mark. Some of the papers only had 1 name to do out of 100 marks, so 1%. Others had 2 marks, whereas AQA tended to have at least 2 or 3. So they had kind of like just an extra mark. Again, naming is like hardly any marks. You can, even if you get every single name wrong, you can still get an A star. But you don't want to, because you'll lose. It's worth about 2% of your A-level naming, so of your A-level chemistry. So yeah, they might seem a bit unfamiliar. Well, I think the AQA ones are slightly harder. Okay, the alpha, this one's quite hard. This one's a little tricky one, because you've got to know the structure of an amino acid. So do you know your structures for the baseline structure for an amino acid, the constant kind of region of an amino acid, or the thing that's the same each time? I can't remember what they call that. But and what would be the name for valine? Now, valine is one of the 20 essential amino acids. Okay, so if you think about the baseline for an amino acid, what do you have? You have a carbon atom, and then what do you have attached to either end? And then you have your R group. Can you remember the 2 functional groups on the amino acid? So you have a carboxylic acid group. And then we have a nitrogen. This is known as the amino. Now, yeah, that's right. The NH2 is an amine, but it's also, when you name it first in chemistry, because it's a side group, it's not as important as carboxylic acids. That's amino, okay? So hence the name amino acid, which is kind of a shorthand. Now we have a hydrogen. Now, a lot of people put the R group down here and the hydrogen there. So this is constant. All amino acids have this. And then the variable region is the R. So all 20 of them have the carboxylic acid group and the amino group. And then they have R, which can vary. And the simplest one, it's just an H. What's that? Glycine or alanine? One of those 2 is the simplest one and has just an H. Now they're telling us that branching off of this is CH, CH3, 2. So I want to go CH, CH3, like that. And then what would the name of that be in chemistry? Now in biology you call that valine, but what would that be IUPAC in chemistry? IUPAC. Sorry, that's a bit of Street Fighter. Talking of Street Fighter.
Say when.
Round 1.
Let's go. Okay, yeah. 2-amethyl, 2-amino, 3-methyl butanoic acid. That sounds pretty heavy. Well done. Yeah, I make you right, dude. Yes. 1, 2, 3, 4. Butanoic. Yes. So if we were numbering it, you're spot on. 1, 2, 3, 4. And then we've got the methyl group coming off of 3 and the amino group coming off of 2. So we're going to go alphabetical. A before M, amino before methyl. So 2-amino, 3-methyl, butanoic acid. Nice. All right, let's bust out a couple of the old. Let me show you some AQA ones. Uh, hold on, hold on. He says, hold on. This is OCR2, but I haven't done any of their aromatic rings, so I thought, well, let's do an aromatic ring. Now, everything that comes up in OCR, potentially any of these could come up in AQA. So it's not like these aren't on the syllabus for AQA, they are. But I'm about to bus on to the AQA ones. I just thought, let me show you a couple with the benzene ring. So what's the systematic name of hydrocarbon C? And ester F has the structure shown below. What is the systematic name for this ester? So this is from the 2024 OCR paper, I think, potentially. Is it? Yeah, 2024 OCR this was. So this is just last year's. Ethyl, not like ethyl 2 for dimethylbenzene. Boom! Yeah. You're absolutely right. So basically, ethyl is slightly higher priority than methyl, but listen, they might. So you're gonna go with ethyl. Now you could number it if you want. If you want, you could call it 1 ethyl 2 4 dimethylbenzene. And when you've got alkyl groups are like CH3. Then the benzene ring is priority. Okay, so we call these the Side groups, and they're just so like you said. That's going to be carbon 1 because it's an ethyl group. That's 2, that's 3, that's 4. So we're going with 1 ether 2 4 dimethylbenzene, or you can just give it the old. You don't need to number it in this situation. So let's go ethyl 2 4. Remember, a comma separates the numbers, hyphens in between everything else. If you over hyphenate, OCR are very generous. They say ignore it if they put additional hyphens in. So ethyl 2 4 dimethyl. Now I don't really need to hyphen between methyl and benzene, but there we go. Yeah, if you did make that mistake, like say you accidentally put ethyl 2 4 dimethyl hyphen benzene, they're not taking the mark off of you for that. So don't worry, because you've got all the right elements in there. No problems. I'm only going through the questions, nothing like nothing too major, just going through the questiones. So I'm not really going through all of the IUPAC rules and everything, but hopefully through the questions you can kind of have a go and see if you can do them. So ester F has the structure shown below. Now this one is also from the 2024 OCR Chemistry Paper 2, Organic. And what do we reckon with ester F? So important 452 is just smashing out the answers at the moment. He's going for ethyl 4-methyl propanoate. Oh, I reckon you might be wrong on the pro. You might be wrong on the pro. And let's have a little look. So you're right, this is ethyl, and in esters that alkyl group comes from the alcohol. Yeah, I think it's pen. So that's the ethyl bit, and then this would be pentanoate. Why is it pentanoate? There are 5 carbons. Now, which is carbon number 1? 1, 2, 3, 4, 5. So, yes, ethyl, 4. So you would name this side group first. So we're going to go ethyl, then we go 4, and then, yeah, ethyl 4-methyl. So the 4-methyl tells you there's a methyl group on 4, pentanoate. Yeah, smash. Let's put that in. So, oh, no. You're stealing things, no good. Okay, that's no good. Alright, what did we say that was? Ethyl dash. Oh my days. 4-methyl pentan. Oh wait. So ethyl 4-methyl pentanoate. Nice. I got there in the end. Don't worry about it. I make mistakes. all the time. Right, we're nearly on to the AQA section, so you'll be able to compare. Now, this is, was just going to do organic. I've thrown a couple of these in, and so this is from the 2017. Oh, so what I did is I went through all the organic paper twos, and then I started, once I run out of organic paper two, UPAC questions, systematic naming business, I started to look at paper three, because that's the blended synoptic kind of paper, which kind of mixes and matches stuff from all over the course, your paper three. And they ask a lot of the kind of inorganic, what is the systematic name for NaNO2? I mean, I didn't know there were so many names for NaNO2. I just called it one name. So, yeah, anyway, I'm not really going to deal with the organics, but I thought I'd throw that weirdo one in there. And then this next question from 2017, you've got Dettol, which is obviously the bleach, like a kind of bleach, is a disinfectant containing antiseptic chloroxylenol, shown below. Chloroxylenol is a weak Bronsted Lowry acid. Okay, so it can give away hydrogens, but what is the systematic name of chlorohexanol? So I've got two here. Now that is sodium. Now I would call this something different. I would call this sodium nitrite, and they would accept that because NO2 is nitrite, NO3 nitrate. So that's, I just like know that without really knowing there's a system for it. But apparently you can check out the oxidation, because if you have three elements in a compound, if you're looking at inorganic compounds, not organic, if you have three elements in a compound and one of them is oxygen, you can give it the old ATE8. Think of hydrogen sulfate, which is hydrosulfuric acid, or calcium carbonate, CaCO3. So I could call this and in the mark scheme they accepted sodium nitrite, which would be my answer as the correct answer, but they actually called this sodium nitrate. And I would say, oh, okay, but you have to, if you're going to call it sodium nitrate, you have to give the Roman numerals for the oxidation state of nitrogen in this. So with organics, you've sometimes got to include oxidation states where they can vary. So, yeah, that's going to be -4 + 1. So that's going to be, because NO2 is going to be -4, because each why have I put -4? I ain't really got a clue. Couldn't tell you why. Yeah, whatever. I was probably trying to say O2 is -4. That is group 1, so it's +1. And so the nitrogen in this particular compound is +3, its oxidation state. And what we need to do is put, oh my gosh, sodium nitrate 3. So apparently that's sodium nitrate 3. Yeah, I think sodium nitrite, that's what I would go with, but that's sodium nitrate 3. And what they wouldn't give you the marks if you put sodium 3 nitrate, because if you put sodium 3, it makes out, when you do the Roman numerals, it tells you the oxidation state of the element that comes before it. So this way it's telling me the oxidation state of the nitrogen, even though kind of you might argue, oh, isn't that the oxygen? But no, it's of the nitrate. It's telling you that it's +3. Anywho, enough of that rubbish and waffling on about the inorganics. We're here for the organic naming. What is the systematic name of chloroxylenol? So you've gone for 4-chloro, like it, 3,5-dimethylphenol. I reckon that is spot on. Now, hydroxy groups are more important than benzene rings on the priority of things. Okay, so the OH group is more important. Now, if you have a carboxylic acid there, or an aldehyde, or whatever, but this is more important. So this becomes phenol. So as a starting point, sorry, I'm dribbling over myself there. I was like, spat that out. Phenol. That is phenol. And then we just want to number these guys up. So we're going to call that 1 there, 2, 3. You're absolutely right. There's the 5, there's the 4, there's the 6. There's nothing on that. So we want to call it, we don't need to call it phen 1-ol. We don't need to number where the ol is, because phenol, the carbon, if it's a phenol, then the carbon is 1. Okay, it's not a hydroxy. So the carbon with the OH is 1. So yeah, you're right. 4-chloro Why chlorine first? Because it's alphabetical. So we want to go alphabetical. Chlorine, C comes before M. So 4-chloro, and then we want to go 3, 5. So you split them by a comma when they're the same identical functional groups. So 4-chloro, 3, 5, and then dimethyl benzene. And you don't need to have a space between the methyl and the benzene unless you are up for it, and they're not really going to punish you for that, or if you add an extra hyphen in. Cool, let's get on to some of them AQAs. Let me just see if which one, what, this 4-chloro 3,5-dimethylbenzene. I think that's the best name for it, 4-chloro 3,5-dimethylbenzene. That normally there is, so normally there are other names for this. So whether we could say one hydro, like, so there's a preferred name, but then for most of organic chemistry there'll be at least 3 names that would be acceptable. Now, following the kind of standard numbering system, that's how I would do it. Whether they would accept sort of, if you Google it, they might. If you Google 4-chloro 3, if you Google, is there another name for 4-chloro 3,5-dimethylbenzene on like Google AI, you will get all of the names, and then some of them they'll say, well, this one isn't really appropriate. So I could do that right now, but I'll probably mash up things if I try to do that. Maybe I should try and do that. Let me try and do that. Show you, because then when you're doing exam papers, Google's your friend. If you have Google, that is your friend. So let's try that. What did we call that? That was is there another name? They're probably going to give me that it's Dettol for 4-chloro. You don't need to put all the hyphens in when you do this. What do we call it? 4-chloro 3,5-dimethyl. What did we say? Benzene. I don't know whether they're going to say 1-hydroxy and number the hydroxy group. So I don't. Oh, you can't actually see what I'm looking at. So I thought you might be able to see what I'm looking at. I probably won't share screen with you, because if I do that, it will 4-chloro 3,5-dimethylbenzene. Yes, you could call it 3,5-dimethyl-4-chlorophenol. So that's an accepted name as well. But the correct IUPAC name for the phenol is 4-chloro 3,5-dimethyl. Oh, you could call it 4-chloro 3,5-dimethylbenzene, or sorry, why am I calling it benzene? I'm smoking crack. You can't call it benzene. I think I went a bit bonkers there. Yeah. There I am saying that your name is really good, and I'm typing out benzene. Yes, it should be 4-chloro 3,5-dimethyl phenol. If I'd said 4-chloro 3,5-dimethyl benzene, I'm not pointing out there's an OH group. So what I'm doing there is very stupid. That was a mistake. I didn't mean to do that. So yeah, I'm naming it that by calling it benzene. Yes, so the proper name, it should be phenol. But what I'm saying is that was just a mistake by me in talking and waffling and typing, because actually important 452, which I think I acknowledged, put the right name there. So it's 4-chloro 3,5-dimethyl phenol. That's what happens sometimes. You're talking about something and typing the wrong things. You try and do 2 things at once. My brain don't cope. But yeah, there are some other names. It said you could name it 3,5-dimethyl 4-chlorophenol as well. So you could. I wouldn't do that. The way in A-level chemistry, we put the C before the M alphabetically. But yeah. Ho hum. Right. I don't think I'd do these. Oh. Now these are inorganic names. I'm going to steer clear of the inorganic names. Let's steer clear of these dirty things. What you're going to do with these, if these came up with inorganic names, just I'm not really doing inorganics, but just in case, what you want to do here is point out the oxidation state, because it tells you here, look, the oxidation number of chlorine is different in 2 rubidium salts, RbClO3 and RbClO4. What is the name of RbClO4? You need to call it rubidium. Now, when you have 3 elements and one is oxygen, and it's inorganic, we don't name the oxygen oxide, we say 8. So this is rubidium chlorate. But you're going to want to put a Roman numeral for the oxidation state of the chlorine. Whoa. Yeah. Do we compare C to di or methyl? Oh no, you compare the C in chloro to the methyl, not to the di, not to the di. Yeah. It's always the name of the side group, not to the number of how many of the side group, not to di or tri. So it's alphabetical to the actual side group, to the M in methyl, to the C in chloro. Good question. Right, so this, I'm not going to write down. This would be rubidium. And then what is the oxidation state here? What's oxygen is -8. Is rubidium group 1? Magnesium, lithium, rubidium's group 1, right? I'll probably mess up again. I need Google as my friend. If rubidium is group 1, because I can't think offhand, then that makes chlorine in this +7 oxidation state to balance out the -8. This would then be called rubidium chlorate 7 in Roman numerals. So we would want to type it out as rubidium chlorate 7 in Roman numerals if that is group 1. Doesn't show a charge. No, it doesn't. Right, rubidium chlorate and then 7. So the 7 is talking about the chlorines, the positive charge on the chlorine, not the rubidium, which is just +1. Why do we not need to put a Roman numeral for rubidium? Because rubidium's in group 1, they're always +1. They don't have any other charge. And then with this is phosphoric acid as well, H3PO3, but we would just change the charge. We just need to explain the charge on the phosphate. So with this, we are going to be explain the charge on the phosphate. So it's phosphoric 5 acid. So what they're really telling us here, nice and easy, phosphoric 5 acid. Why? Because that is -8 for the oxygen, because you've got 4 times -2. Hydrogen is +3. This means that the phosphate in phosphoric 5 acid is +5. If you look down here, that is +3, 1 for each of the positive hydrogens. Oh my god, that's disgusting. That is -6 because we've only got 3 oxygens, and that means that that is +3. So this is phosphoric 3 in Roman numerals acid. Oh my days. Phosphoric, I'm gonna bust that out. Acid, phosphoric 3 acid. Anywho, enough of that disgusting inorganic stuff. I'm here for the this stuff. So this is AQA, peeps. So now you can tell me, does the AQA seem nicer? Out of coffee, no good. How many? Oh, we ain't got long. I haven't left long for the old AQA questions, have I? Yeah, bottom of group 1. Yeah, it goes up near francium. That's right. Very reactive. Give the IUPAC name of CH3, CH2, 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 CHOH, CN. This is where you got to know priority rules. Not your Channing Gold priority rules. But you got to... Oh, so you could just number this bad boy. So we know... Is the alcohol more important than the nitrile? I think the nitrile is more important here, guys. So we're going to go 1. The OH is coming off of 2, 3, 4, 5, 6. Now, if the alcohol was more important, then we're going to go hexane 2-ol, but the nitrile is more important. And you just have to know that. So for A-level chemistry, you do need to know this is a common one, and the ones they ask in A-level chemistry are the ones that fit with the chemical reactions you do. So you know you form hydroxynitriles, and yes, it's 2-hydroxyhexane nitrile. It's up to you whether you include the E or not. So 2-hydroxy-hex. Now you can give it the old AN nitrile like that, or you can say that looks butters because there's two N's together. I'm going to slap an E in between and go 2-hydroxyhexane nitrile. They shouldn't punish you if you don't put that E. But then you never know. AQA are a bit funny like that. So I think when there's two N's together, they won't allow you to drop the E. So like sometimes you'll be able to drop the E. Say this was oic acid. Say this was hexanoic acid. Then you could call it 2-hydroxyhexane, drop the E, OIC acid. That would be fine. But I think in this situation, they're going to be really, really strict because AQA can be like that. And they're going to underline that and say, if you don't have the E, you don't get the mark because they don't like two N's together. It's just not their cup of tea. All right, what is this molecule here? All of these questions, that all of these three things on the same page are from the 2017 AQA paper 2. Yeah, they're strict with an E. So this is from the 2017 paper, I believe. This one, I couldn't find this in OCR in the ones I looked at, but I hadn't looked at their paper 3, haven't gone through all their paper 3 or their paper 1, but they haven't asked this one in OCR. But you do have to know this if you're doing OCR, so this is good practice because this might come up for you. You do have to know this. This is called an N-substituted amide. Now, when you have a carbonyl group like that and it is directly attached to a nitrogen atom, that is known as an amide, okay? But it's N-substituted because we have a side group attached to the amide. And so there's a number of ways to name this. The way I name this is, of course, that is ethyl. And then this is 3 carbons in this, propanamide. I should really type, but when I type, I tend to flop on this. So that is propanamide, but I'm going to want a number, and yeah, I think we can just call it E. Oh, we want to name the N substitute as well. So I'm going to call it, now if we were numbering, let's pretend there was, so this is going to be ethyl propanamide, but we need to let them know the ethyl is on the N. So what we do is we call it this. It's a basically N substituted amide. So we're going to call it N ethyl propanamide. And there you go. N ethyl propanamide. I know my things are all underlined in red, but I don't like the way I'm spelling that. So notice I've dropped the E on propane there. Now, if you had put the E in propane amide, they would accept that as well. And look, that gets rid of my red line. Let's do that. Okay, but if you had dropped the E there, they would be, I'm sure AQA would be fine with you there if you dropped the E and didn't call it N-ethyl propane amide, because you don't have 2 letters next to each other. It kind of looks okay to drop the E. Now, let's imagine, why did I bother numbering that? Let's imagine you then had like a hydroxy group coming off there. Obviously, the ester or the amide link is above the alcohol, so then that would be N-ethyl 2-hydroxypropanamide. So you just add that in there. So as well, just make sure that the number 1 on the kind of propanoate ion, or the amide, sorry, the number 1 on the amide is the one attached to the amide. Okay, they're all derivatives of carboxylic acids anyway. Give the IUPAC name of isomer P. So we got IUPAC in on P. What is IUPAC P over here? So remember, this is a stereoisomer, folks. Look at, there's no rotation around the double bond. We need to use our cis and trans, or our Charning Gold prelog principle things, and we need to use the old Charning Gold and work out where the low priority and high priority are. And we also need to name it, so we can do that after. Let's name it first of all. Most important functional group, is it the alkene or is it the carboxylic acid? The rest are just alkyl groups, and they're really low down. They're like the peasants in the IUPAC naming world. They're the lowest in the hierarchy. So carboxylic acid is the Mac Daddy. That's the top one. So this is ending in oic acid, and then we need to number the alkene. So we're going to do that first, and we're going to call this bish bash bosh. One. Oh no, we're not going one there. We need to start with the carboxylic acid, don't we? 1, 2, 3, 4. So the longest unbroken chain is 5. So we're looking at pentanoic acid. Yes, it's En for N. So pent-2-N-oic acid. Nice. And then is it Z or E? So we're going to go, and we've got a methyl there, haven't we? So we're going to call it pent-2-En, not an, because that would be single. Pent-2-N anoic acid. Now, whether you want to go pent-2-N, 1 anoic acid is up to you, but I'm just going to go oic acid like that. I'm not going to bother because the carboxylic acid is my priority group. I'm not going to number it, but I think you could if you wanted to. They wouldn't. Hopefully, they shouldn't take a mark off you if you call it pent-2-N 1-oic acid. Now, that doesn't tell me about my sides. So we got a side methyl group down here, little side thing on the side. So we're going to call it 2-methyl. We're going to slap that in there as well. So let's slap that in. 2-methyl dash. I don't need the dash. I don't need the hyphen here. Again, if you're in OCR, they won't take a mark off you for that. I've noticed that. So, and I mean, I've got a capital there. I can get rid of that. But it'd be 2-methyl pent-2-N-oic acid. And you are absolutely right. This is Z. So I do need a hyphen between the Z. This is Zusammen, which means sisters, apparently. I couldn't speak 100% on that. But we look at this. Carbon, oxygen. This is high priority. This is got an atomic number of 6. That also has 6, but then it has an oxygen attached, which has an atomic number of 8, and hydrogen has 1. So that's the way some people like to do it, to work out the priority. It's just as good as adding up the whole atomic number if you want to do it that way. And then we've got the ethyl. There is going to be higher priority than this hydrogen down here. So that is low priority. That means that the 2 high priorities are on the same side, and the 2 lows are on the same side, so it's sisters, Zusammen. Methyl, not ethyl. On the left one, why is ethyl first? Is it because it's first alphabetically? The same side. Yeah, I like that. Zusammen, Z, the same side. On the left one, why is ethyl first? Is it first alphabetically? Okay, nice question. So over here you're talking about, I get what you're on about there. So good question. No, when we name carboxylic acid derivatives, like say this was an ester, the only difference with this and an ester is we would have an O here. If this was an ester, there'd be an oxygen there instead of that NH group, and so this would be ethyl propanoate, and that is that you always number the bit that came from the alcohol first, but this didn't come from an alcohol, and this is not an ester, this is an amide, and it's an N substituted amide. So if we didn't have that ethyl group at all, this would be propanamide. Even if that was a methyl group on this side, it would be methanamide. We would name the side group first. Whatever's on this side of the nitrogen is not part of the amide. It's like attached to the nitrogen on the amide. So this is the substituted bit. So this is an N substituted amide. So if you imagine that's not there, and this is only for these N substituted amides. If that's not there, this is just propanamide. Propanamide. Because we have a side group attached to the nitrogen, this is now ethyl propanamide. And that could be butyl propanamide or pentyl propanamide, depending on how long that side group is. It's even worse, which I'm not going to do now, but it's even worse if you had another ethyl group. Instead of that hydrogen, you could have another one here. So Yeah, you could have another one there. Then you've got NN diethyl propanamide. Then you do two N's split by a comma, and you'd be like diethyl propanamide. So yeah, that one is not alphabetical as to why we did that. That will always be the side group, whatever's attached to the N. The amide, that is, this side is basically all part of the amide. The amide ends with the carbonyl group and the, well, basically an amide molecule ends with the amide. So that is the amide bit, propanamide. Then you're saying substituted onto the N is an ethyl group. So N-ethyl propanamide. Anywho, enough whiffle waffle waffle. Let's move on. Yeah, pretty disgusting. And you could imagine if those two if you substitute that H, the other H, and it's NN, so it's like two side groups, sides coming off the nitrogen. It's all right if it's diethyl, but then of course you could have a butyl group and an ethyl group, and then you've got to say NN, I guess, alphabetical, butyl, ethyl, propanamide. Anyway, yeah, I haven't seen any of those going through. So I got through all of the AQA organic paper 2s from 2017 to 2024, but did I? Yeah, I did. Yeah, I got through all of OCR and AQA. These are all the questions from 2017 to 2024, so I got through a lot and didn't come across any NNs, so any double substitutions. But there are some apps on your phone that you can get and you can download off the Google Play Store. Obviously, you've got to have adverts and all that. There are some IUPAC naming apps. The only problem with that is they don't follow the AQA specifications, so they will they use lots of names that won't be necessary for you to use. So, and you can't strip it down to just please ask me the ones for A-level chemistry. So that was a problem. Okay, but you can get, there's various different apps. I did find one that was reasonably close, but then it does loads of ones that they don't really ask. IUPAC name for this, again, you've got this fight between our functional groups. We've got an OH, we've got a methyl, the side E, and we've got a BR. So you have to know your priority rules. Probably flop hard on this one. What is that? Yeah, I've got that it's propan. We've got 1, 2, 3 main carbons. Then is the OH coming off the second carbon? Can't be. That's H2. Why is that CH2? Is the OH coming off the first one? No, I think you were right. What did you say? 3 broma 2 methyl, 3 broma 2 methyl propan 1 ol. Yeah. Yeah. You're right. The OH is coming off that first carbon. Otherwise, it couldn't be CH2. Would it be CH3? So that OH is coming off the first carbon there. Then we have a carbon with a hydrogen and a methyl group coming off. So you're right there. That's that bracketed methyl there. And then you've got CH, CH, and BR. No, you're absolutely right. It has to be 4. Why am I writing in purple? I don't know when that happened. Right, that is the hydroxy group is the most important here. So we're not calling this hydroxy. We're calling this ol. OL is ending OL. We're going to go propan. It doesn't matter if I name that as 3, whatever. It's going to be propan. I want to go 1. Yeah, I think you got that right. 2 methyl, 3 bromo. Oh, 3 bromo, alphabetical. 3 bromo, 2 methyl, propan 1 ol. Yes, absolutement. So this was, for your reference, from, I don't know what paper this was from, but it's from an AQA paper in the last 5 years. But I didn't make a note of what paper it was from. I can't remember off the top of my head. So what do we call that? 3 bromo. Any questions, people? 3 bromo, 2 methyl. What are we saying? Propan 1 ol. I don't need a hyphen in between the methyl and the propan 1 ol. They shouldn't take a mark off for it, and I've done it now. They're going to go delete it, but methyl can just connect straight to propan. No, I'm not sure how to make this public, this document with all of these names, all of these from the OCR and the AQA. I'm not sure how I make that document public. I haven't worked out how. I'm a bit of a techno. What's someone who's absolutely crap with technology? So as you can see, I use a PowerPoint online on live streaming. Like this is PowerPoint. So yeah, I'm not 100% sure how to make it public. I would attach it to the live in the description if I know how to do that. I'll do that because I've made a document. I just got to make it public or whatever. Oh yeah, I don't know how to do that. Do I have to have a Google Drive to do that or something? Anyway, yeah, as you can see, low IQ. Right, the organic product in question 7.1 can be converted onto the alcohol shown. Give the IUPAC name of the alcohol. So here, give the reagent need. Oh, don't worry about the reagent or the mechanism. I'm just doing the name. So what is the name of this alcohol? Nice. Is this a phenol or a propanol? That's the big fat question. So, which has higher priority? Hydroxy or the aromatic group, the benzene ring? It's the OH has higher priority in this situation. So this is a sideman, the benzene. So we're going to need to number it. What we're going to do is, and you just have to know this off by heart. Now, if the OH is attached directly to the ring, we call it phenol. This is not going to be phenol. This is going to be phenyl. Because the OH is not directly attached to the ring. If you have an aldehyde attached directly to the ring, then it's like benzene carbaldehyde, or you can probably just call it benzene aldehyde. If you have a carboxylic acid, you can call it benzene carboxylic acid or benzenoic acid. Yeah. Yeah, what is this going to be called? 3-hydroxy, oh nice, 3-hydroxy phenyl propane. Sounds pretty good. Although, I think they've given us a clue here, Olu. They've given us a clue here because they've called it an alcohol. So once they say it's an alcohol, we're going to end it with OL, okay? Rather than an alkane, because when you say phenyl propane, we're saying it's an alkane. I think the fact they've said alcohol, we're going to end with ol. So you propan 1-ol. We're going to number it as well. And if the alcohol is the most important thing here, we're going to do that 1, 2, 3. I'm going to call it propan 1-ol, and we're going to number the benzene ring as well. So we're going to call it 1 phenyl propan 1-ol. 1 phenopropan 1-ol. Yeah, there's a lot of stuff to remember, but you seem to be doing very well on the naming. So you seem to be smashing the naming. And remember, the naming is only like 2 or 3% of your final mark. Not even that. Like max, it's 3%. What I mean by that, by the way, is I went through and everywhere it said name this. There are other questions where they say draw this from this name or identify the structure. I didn't cover those things. I just went for where they basically say give us the name of this, mate. So yeah, 3-hydroxy phenyl propane. I'm not sure whether that 3-hydroxy phenyl propane. Yeah, that would be if you put the propane above. In that case, you're putting the propane above the alcohol group. So this has to be 1 phenyl propane 1-ol. Again, I could drop the E from the propane. I should be able to drop the E. All right. Yeah, it can do as well. It can do as well. Oh, that's quite easy, right? I mean, if you end up going on to study chemistry at university, or then you'll start to find they have like other names that they use, that are IUPAC names that they don't use. Like ethene has a name. Like, is it ethene? That's hold on. Ethene is called vinyl. When I was at university, did we call it vinyl when it was a side group? When you had an ethene molecule, I think we called it vinyl. Like, you know, like if you called old records that people used to mix tunes on and stuff like that, they used to call those vinyls, like the black records, LPs or whatever. I think that's like polyethylene. So I think it's like, yeah. Anywho, huh? Don't need to do that. That's but-1,3-diene. Absolutement. Well done, Jack. I'm shortening people's names. How do I get to my my boom? I haven't given out a boom in a while. Well done, Jack. Boom! All right, now we've got isomer X. Give the IUPAC name for isomer X. So this is not a benzene ring. What is that? That is a cycloalkane. That's not as important as this, but what are we calling this? Cyclopentanone. Yep, important 4-5. You're going to get a little boom for that one as well. Well done. Boom! Right, I'm over booming. I'm over booming now. Yeah, so you're right. That is buta-1,3-diene, and here we have cyclopentanone. And then name this ester. So this is a nice simple one, and this, if you're wondering where to find these particular questions I have on the screen right now, I did make a note of these because I didn't for all of them. This was the 2019 paper, AQA Chemistry, Paper 2. 3 of the marks in the paper were for IUPAC naming. Name the ester. Ethyl ethan amide. Ah, not amide, Olu. Close. It's because I was dealing with amides earlier. There's no nitrogen here, so this is just ester business. So it's ethyl, and then 1, 2, 3. So what we do with this, there's no nitrogen here, so we do start exactly the same as an N-substituted amide. You're going to name this ethyl. There's no N, so it's ethyl, and then there's no nitrogen there. There's an oxygen, and when there's an oxygen there, it is a carboxylate ion. So carboxylates, that is going to be propanoate, ethyl propanoate. Now, all of these are derivatives of carboxylic acids. Carboxylic acid is the Mac Daddy, and these are all derivatives of carboxylic acids. They all come from carboxylic acids. At the end of the day, if I want to make that a carboxylic acid, I just swap that ethyl for an H, and that's propanoic acid. So this is ethyl propanoate. Propanoate would technically is the ion with the little minus on the oxygen that the ethyl has joined onto. You got the amide because back here I was over waffling about this amide, and where all the difference between an amide and an ester is that you have an oxygen there, but this is an N-substituted amide, which means it has a side group. It's basically like an ester, but you have an NH instead of an O. Anyway, enough of my whiffle waffle. Let's get on and do another one. Yeah, okay, I did not like this, peeps. I do not like this. I do not like this. This was on an AQA. Did they make you name it? Oh, gosh. I've actually got this on. Oh, I've got the answer on the screen. That was dumb. Is that the one? Oh, no. Yeah, that's not what AQA... I've got a little answer on the screen now. I'm shrinking it down so you can't see it. That's not the AQA answer. The AQA answer for that is disgusting. And actually, they didn't want, you didn't have to name this. What they did is they gave you half of the name and you just had to, it was dead easy peasy, lemon squeezy. You just had to number the hydroxy group on that. So that's, it said, notice it says complete. So before anyone has a heart attack, I thought I'd put the whole thing up, but it says complete this IUPAC name. They actually gave you the second half of the name. They named all this for us, and you just had to number the hydroxy group, so it was kind of easy. It was dead easy, really, but I just put it up there because I didn't like the naming system. Name the organic product here. So what is this? This is one of those where they had a mechanism, organic synthesis, step 1, step 2, step 3, step 4, and it said name the organic product in step 2. This is from the 2020 paper 2 AQA, and if you can work that out, nice. So this is not a phenol because the OH is there, but the OH is more important than the benzene ring, so it's a phenyl. This is a sideman there. So yeah, that's disgusting, that one there. What did you go for? 3-hydroxy pentan. Yeah, I kind of like that. That's decent. 1 pentan, 1 3 4 trioic acid. I like that. 3-hydroxypentan 1,3,4 trioic acid sounds nice to me. But how AQA named this, it was dead easy. So without panicking on that one, see if you can do this top one. I'll show you for the bottom one. It's trioic. Oh no, but it'd be dioic if you're going to end with yeah. Blah. Horrible. Okay, this is what they called it. They called it this, propan, and they gave you this, so you didn't have to name it. Propan 1, 2, 3 tricarboxylic acid. So they called it that, and they said complete the name. So just in case you're thinking, oh my god, I am cooked, you're not, because they just said complete the name. Propan 1,3 tricarboxylic acid. So they're saying, look, they're including the 3 carboxylic acids there. They're telling you the main chain is only 3. So they were counting the main chain as just that. 1, 2, 3. And then saying there are 3 carboxylic acids coming off of carbon 1, 2, and 3. So all you had to do to get the mark here in the AQA exam in 2020 was write this, 2-hydroxy. And so you'll pick the mark up. I just didn't like the name, so I thought I'd put it in there just so it was disgusting. But they wouldn't ask you to name that. This is the name that I would have called it. But yeah, I quite like, I actually prefer, who put up the 3-hydroxy? I prefer Jack's name. That might be a possible correct name, your name there. And this is the name 3-carboxy, because if a carboxylic acid is a side group, I made a carboxylic acid a side group. So 1, 2, 3, 4, 5, and then I made this a side group. And if I did it my way, it'd be this one. This one would be acceptable, but you didn't have to name it. So this wasn't on the mark scheme because you didn't have to name it. You just had to fill the first bit in. But you could name it like that. You could number these as pentanoic acid, and then you could have dioic acid. So it's like 1,5 dioic acid, and then you could say on the 3rd carbon, if it was pent, on the 3rd carbon you've got a carboxy group and a hydroxy group. So that was just another way. But yeah, anyway, enough of that whiffle waffle, because that's not coming up in your exam. So all you had to do was do this for AQA. You see, they ain't going to give you something disgusting like that. Okay, name this organic product. What we're going to do here, this is the most important thing. This is a more important, higher priority functional group than that. So we're going with, it's ethanol. We're going with, that's carbon 1, that's carbon 2. Why is that carbon 1? Because it's attached directly to that. And that means that we have 1-phenol-ethan-1-ol. Everyone cool with that? 1-phenol. So you're saying that the benzene ring is coming off a carbon 1 of the ethanol. So 1-phenol, 1. No, I can just call it 1-phenol-ethan-1-ol. Ethan-1-ol. No need for the caps, Tom, you wally. So, yeah. All right. Let's smash. Oh, I've overrun. Never mind. I'm just going to finish the last couple of slides. So this is from the 2021 and the 2022 AQA paper 2. And name compound Z. Give the name of CH3CH2COCH2I. Name the organic product C6H5CHO. Oh, carboxylic group, calling it a carboxy group. Now, carboxylic acid is the most important functional group. So you don't have to, what they're saying, like, it's just a kind of disagreement on how to say it, but these are both accepted names. So if you want to use one of the carboxylic acids as a side group, then you can call it dioic acid. By calling it dioic acid for this second one, you don't have to, and they never ask for that name, and they'll never ask you to name this. So they'll never ask you to name this. But to explain the name that I had here, you would go 1, 2, 3, 4, 5, and you'd go, right, it's 1,5 dioic acid. So it's pentan 1,5 dioic acid. and then we're just going to pretend that this on carbon 3 is a carboxylic acid side group and a hydroxy side group. So I'm going to call it 3-hydroxy or 3-carboxy because carboxylic acid is a side group here and alphabetically before H, C before H. So we're going to go 3-carboxy, 3-hydroxy, pentane, 1,5-dioic acid. Now, they're never going to ask you to do that. But I kind of preferred that name than the 1,2,3 tricarboxylic acid, but maybe the 1,2,3 is decent. But then you're saying propan 1,2,3. So yeah, anyway, start to get a bit hard there. So so we just got I just got a few more questions, and then that's all of the organic paper 2s. So you can go through this, and this is all of organic paper 2 for OCR AQA. I also did the OCR paper 3. I didn't check out the paper 3. I didn't get around to looking at the IUPAC names for the any IUPAC questions or systematic naming questions that came up on paper 3 AQA. I didn't get around to doing that. Okay, so name, this is from 2021, name compound Z. So what we're going to do, we're going to go how many carbons in that? There's 2, right? OH or NH. What is more important? OH or NH? 1-hydroxyethan amide. Okay. 2-hydroxyethan amine. I've got a feeling, and this is a bummer, I'm going to show you the list. It's not an amide, this one. So just to give you the difference, Oliver, between an amide has a CO bond attached to an N, like that. That is known as amide. And these are very confusing when you're doing chemistry A level. That is an amide. And then the amine, I don't know if my face is over that. Oh, my face is over that. That's clever of me, isn't it? You buck. Shrink my face. Bloop. Right. No need for the sound effects, really. All right. And then an amine is going to look like. Oh yeah, amine is going to be like that. So there's no COO bond. It's not a carboxylic acid derivative. So this is come from a carboxylic acid, and amine hasn't. So this is not an amide, this is an amine. Now you need to ask yourself, are amines more important than amides? What is more, oh sorry, this is not an amide, this is an amine group. So we've got amine and then we've got the hydroxy. What is more important? Because it's either going to be amino ethanol or it's going to be hydroxy amine. So is it amino, and we're going to need to number, is it amino ethanol or hydroxy amine? And so what we do is we go, what's more important, alcohol or amine? There's no nice way to do this. I need to find a way. I haven't thought of, I haven't given it enough thought yet of something stupid to come up with. But look, amides are high up because they're carboxylic acids. So the amide comes from a carboxylic acid, so it's above an alcohol. But alcohols, as you can see here, come above amines. Amines are almost down to peasant status. They're nearly down with alkenes, alkynes, and alkanes, and the halo groups. So amino is often a side group rather than being an amine. So the alcohol's higher up in a priority. Now, I've seen some mnemonics. You can Google mnemonics for naming, but look how many bloody A's there are. You could make up a story. I don't know. Carb, oh, yeah, I don't know. No, I don't know what the story is. Yeah, alkane says halo. No. No, yeah, you could come up with a mnemonic, but that's going to be hard. Look how many A's there are in that thing. So, quite a lot of these don't apply for A level, like sulfonic acids. Thiols, they sometimes ask thiols. Okay, where was I? I was waffling. So, now we know that 1-amino ethanol. Thank you. Awesome. Well done. 1-amino ethanol. Excellente. And again, yeah, 1-amino. Oh no, not one. Is it 1-amino or is it 2-amino? I think it's 2-amino ethanol. Close. And it could be 2-amino ethan 1-ol. So why is it 2-amino? The OH group is whatever carbon the OH group is on. Why have I drawn it down there? Who knows? But whatever, yeah, I'm waffling, whiffle waffle. So there we go. That is going to be carbon 1. What's that coming out like that? Never mind. And that's going to be carbon 2. So 2-amino ethanol or ethanol. Yeah. So kind of getting to know the priority rules. What I would do if I was you, if you're going to do a paper, you could have the priority rules, print that off. Printers are a bit out now. My printer bust about 5 years ago and I don't print nothing. Don't know if you're the same, because everything's online and streaming. I don't even bother printing anything anymore. But if you're an A-level student, you probably should. So you could write that priority list out, blue tack that to the wall next to your lap where you sit and work, wherever you sit and work, bedroom, living room, where your laptop is. And so when you're doing a paper, you can just check that, because while you're practicing your exams and your questions, you're not getting points for. So try and work it out without looking at the list, then look at the list and you'll just get the general feel for what's more important. You're only really dealing with half of those groups at A level. Half of those groups they're never ever going to ask you about, as you can see, because these are all the questions they've asked about. So knowing the difference between hydroxy and amines, amides, anything that comes from a carboxylic acid, so it has this. Anything that is a COO with something coming off the side there is like up in the top section of priority. But yeah, that's not in this molecule. Right, give the name of this. This one's quite difficult. So again, we'd have to look at our list. This is a bit controversial, but halo on our list, okay, this is something a bit controversial, which is why I don't like looking at these lists. Halos are down here, and this makes you think, oh, halos are the biggest waste man of all. No, halos are down with the peasants here. These guys are, they shouldn't do this in the list. These guys, prefix only. So these guys are prefix only. Basically, they're saying they're only ever going to be prefix. You never ever have something ending in bromo or chloro. They're only ever a prefix at the start of a name. But these guys are all kind of equal crapness. They're equal low peasants. So what that means is go alphabetically when you number them. So, yeah, methyl and chloro are equally rubbish. So then choose number them as to which one is closer to the main functional group, etc. Yeah. Anyway, enough of I don't know what I'm waffling about. We were on here. I've only got a couple more questions. So this one is going to be, I'm drawing out the display. What is that? 1-iodo, like it, butan 2-O. Imbalido, that sounds awesome. Oh, Oliver, nice. 1-iodo, butan 2-O. And you smashed that. Well done. You're getting a boom for that. So, well done. Boom! We're nearly there, nearly finished. Right, just 2 more questions, I think. So, yeah, butan 2-O, you're absolutely 1-iodo, butan 2-O. Some people might say, why is that not 1? Ketone is higher than there. Yeah, but you got to number the chain, giving the lowest number that you can to the high priority group. So this is the chain that contains the ketone, which is the high priority group. We can't number that 1. I can't number that 1 and then go there. So I have to do 1 there. This has to be 2. This has to be 3 and 4. So I'm definitely going to number it that way. So it's definitely butan 2-O, 1-iodo. So 1-iodo, butan 2-O. And the ketone is more important than the halogen. But yeah, you get the idea. Name this organic product. So if you don't know, this is a benzene ring. Yes, it is. C6H5 is your code. We're dealing with benzene. And then CHO. That is going to be a aldehyde, isn't it? CHO is aldehyde. So, do we call this benzanal? This is called benzene carbaldehyde. I think you can call it benzene aldehyde as well, and they might give you the mark, but you can just call it benzene carbaldehyde. If you have a carboxylic acid there, you can call it benzene carboxylic acid, or I think you can call it benzenoic acid. Can you call this benzanal? I would just call this benzene aldehyde or benzaldehyde. There's like a load of versions of the same thing. I'm going to call it benzaldehyde. So basically benzene with an aldehyde attached. Pretty horrible. For AQA, yeah, benzaldehyde. Yeah, benzaldehyde. You guys are right. I think you can call it benzene carbaldehyde as well, but you'd have to see. I'd have to look up the mark scheme. I haven't done that, but used to be able to call it benzene carbaldehyde, or maybe benzene carbaldehyde. Anyway, well, rubbish. Last one. This is from the 2023 paper and the 2024. So this is 2023, I believe. Use our UPAC rules to name isomer W. And then from the 2024, ester F can be prepared from propan-2-ol and ethanoic acid. How easy is that? Don't worry about the equation. You can do that from the name, propan-2-ol. Oh, no, it's not that easy, actually. I'd have to draw that baby out, I think. 3-bromo-propan-nitrile. Let me check it. Yeah, so the nitrile is high up. Remember our order, guys. Nitrile is where it's number 4 on the list after all the carboxylic acids. So number 4 is nitrile, the CN. So you can be comfortably know in A-level chemistry, nitriles are going to be priority unless you have something that came from a carboxylic acid like an amide, an acyl chloride, or a carboxylic acid there. This is going to be the bad boy name. So we have nitrile, we have propan nitrile, 1, 2, 3, but I'm going to make a mistake because I wrote 1 there. 1 has to be there because that's the most important. 1, 2, 3. Yeah, 3-bromo propan nitrile. Nice. I need to put an E in here. I make that mistake sometimes because I'm used to dropping the E. Where's the, what the arse? Oh, there we go. Jeez on bread, I messed that up. 3-bromo propane nitrile. Okay, lovely, lovely, lovely. Oh yeah, I'll zing to the list. Listen, if you Google AI and you just go, give me the list. There are some websites. I'll show you the website. Well, let me go. I'll just quickly smash this out, then we'll look at the list and I'll show you the website where you can get all of the stuff and an explanation of the order and all of that if you're interested. So ester F can be prepared from propan-2-ol and ethanoic acid. So listen, if I'm drawing this out, what I'm doing, I'm going to draw this out. I know it says do the reaction. So I know that ethanoic acid is the ethanoate ion, right? So that's going to be, this is going to look like that. It's going to have the double bond O. And that's where my OH was. That's going to go missing because we're going to make an ester. So that's going to go missing. Let's get rid of that, baby. And then we are going to stick on propan-2-ol. But that means that the bit of the alcohol, the propan, where it had the OH, it's joining on the second carbon. So what do we call this? Now, in industry, I remember from my uni days, this has a special name when you're at university, but that you don't need to know it at A level, luckily. So you'd like to think, sir, can't I just call this propyl? And this was from the 2024, I believe, AQA paper. Yes, it was. So this would have screwed a few people up. And so essentially, if it was just propanol and it was propan-1-ol, we would just call it propyl ethanoate. But because it's on the second carbon, it gives us issues. So what you can do is you can split these into 2 side groups. So it can be, instead of propyl ethanoate, we can do it like that. Methyl coming off of an ethyl. So we can do it like that instead. Now there was about 6 names on the 2024 paper for this. There was about 6 different names that were accepted. I might be exaggerating. I'm probably exaggerating when I say 6. But I preferred this name, methyl, same for the CH3 there, then ethyl propanoate. That's the kind of, I think that was the first place name. When I was at university, and if you work in the chemical industry, there is, because this often happens where you get like propan 2-ol attacking and attaching with an ester there, or just on the side of a benzene ring or something. They actually call that isopropyl, and they had to give you that in the exam, even though it's something you don't know. That's known as iso, meaning the same on each side, propyl. So a methyl on each side attached in the middle. So it's like even. When you do the structural formula, so like if I had a benzene ring, if you had a and you won't be taught this at like A level, but if you had a benzene ring, you know, with that unit there, that is called isopropyl, okay, because there's 3 carbons, but it's attached on the second carbon. So you might see that in naming and on websites. That's known as isopropyl, and it's very common in the industry for that to join on. I think you could call it ethyl. No, they definitely accepted ethyl methyl. Yeah, so you could say ethyl methyl propanoate. It had to end with the propanoate. Did I call it ethanoate? Oh no, it's ethanoate. Oh my gosh, what the arse? Look at that. I've called it ethanoate there, and then I've written propanoate there. Sorry, excuse my language. There you go. Yeah. What the? Oh, it's getting worse. It's getting late, that's why. Methyl ethyl ethanoate. Yeah, it's ethanoate. I don't know where I got pro. I started talking about this being a propyl group. And then, you know, that got my brain thinking that, and getting old, grey beard. Right, okay. So here's a list. Let me zing these off. But I don't think this can be confusing, because this doesn't tell you that some of these are equal in priority. So you've got this list here, but it doesn't tell you that some of these are equal in priority. Let me just see if I can share my screen with you onto Google, and yeah, I can do. Hold on, priority IUPAC. All right, I'm going to share with you screen. Hold on, he says. Bloody hell. What have I done? The screen's gone black. That's no good. Yeah. In theory, I was going to share with you. Right, hold on. Let's see. Yay. Boom. There we are. Okay. Let's share that with you. That took me a couple of seconds. So you can see here. What am I doing? Where am I? Here I am. Okay, so you can see, look, that's the screenshot I took, roughly. And they give you a little explanation. Lower priority, this is telling you these are below amine, and these are all equal in their crapness. These are all equally rubbish and peasantry and low down. I know there's a kind of order, but these are a specific order of priority, and then like level 12, they're all the same. Now there are some websites that cover this, so if you just Google it, first thing up, you've got Master Organic Chemistry. I didn't look at it till today. You click on that, and this goes a bit more about, like, this goes and gives you nomenclature. Tells you why it's difficult and all that. But some of these go way above the pay grade of what we need. Like, we don't need sulfonic acids and stuff like that. But this will go through and give you a bit of an explanation prefix, whatever. So like nitrile. Now nitrile is pretty much higher up than anything you're going to deal with, but if you've got a carboxylic acid and a nitrile coming off the side, and nitrile is cyano. So let's imagine a carboxylic acid is there, and then we have a CN somewhere further along. Then we're going to call it cyano, and it's a carboxylic acid, which will be the main group. So this will tell you, like, you get aldehyde, formaldehyde, or whatever. Okay, anywho. Yeah, so this is just a lot more detail than you probably need to go, but they've got like all of this info here. And they've got questions on there and quizzes and things like that. Also, not that I'm saying that you should do this. I wouldn't recommend these massively, But I've got a few of these on my mobile phone. So I got this one. You can't really see that, but that is chemical nomenclature. That is free on Google Store. I only like that one because it doesn't have ads, and then you can press play, and then you can, I know what a loser am I, you can do some naming and it will give you names and multiple choice. You can just click through and see if you can do it. And that's where you'll get introduced to loads of ones though that aren't chemistry A level. So unfortunately, not loads, and they're not super hard, but they're all accepted, but you'll get other versions of what you normally say, and then that might throw you off a bit, but I use that sometimes. So, but there's hundreds of those. You go onto Google, well, not hundreds, there's 4 or 5 different nomenclature apps on the Google's Play Store that are free, although you might get adverts and they might try and sell you stuff, so I'm not recommending them massively, but there we go. Right, what am I doing? Oh my gosh, what's that? Right, I don't even know what's happening. I want to go back and I want to get out of here because we've got a black screen. What the ass? That's got the chat up. So that's what a YouTube chat looks like. But I'm never ever on this screen with the chat, actually. So never ever on that. And here we go. Okay. I'm out of here, people. I'm out of here. Yeah, that's what happens when I start fiddling about. I told you I'm technically challenged mentally. All right, I'm off. So I will see you lot later. You have been amazing. Bit much, wasn't it? Yeah. All right. It's over. I'll see you guys later. Take care, and yeah, don't forget to hit the like, share, subscribe, all of that business.
You're still here? It's